Hello everyone. In this video, I want to talk about hydrolysis of salt, which is an important topic in JAM, in WAEC, and in NECO. Now, when we say hydrolysis of salt is simply dissolving of salt in water to produce acid and bases, or dissolution of salt to produce. When you dissolve salt, you are going to get an acid and you are going to get a base. Okay, and very soon you're going to see the reason why we are learning hydrolysis of water, and that's because sometimes when you dissolve a salt in solution, a salt solution can have a pH greater than 7. It can have greater than 7 simply means it is a base. That means it has basic property. The solution can have a pH less than 7. That means it has acidic property. Or the pH can be equal to 7. That means it is neutral. So that means it is possible that a salt can actually have basic property, and some salts can have acidic property, and some salts can be neutral. And the reason for this is depending on the type of acid or base that react together. In order to determine this, you need to know strong acids, strong bases, weak acids, and weak bases. So for strong acids, I'm going to mention three strong ones based on our level. We have hydrochloric acid, we have HNO3, and we have H2SO4. Okay, so these ones stand out in the category of strong acids. All other acids are weak acids. Okay, so you have something like H3PO4 here, you have H2CO3 here, you have CH3COOH here, you have hydrogen sulfide here, and the likes. Now, somebody is asking what a strong acid is and a weak acid is. The main difference is that a strong acid dissociates completely in water. Dissociates completely in water. Okay, that means the dissociation is complete, is a complete dissociation. Like hydrogen chloride, when it is dissolved in water, completely dissociates into hydrogen ion and chloride ion. But that's not the same thing with a weak acid. A weak acid is one that dissociates partially in water. So that means if I have H3PO4, for example, there will be a partial dissociation. I use a smaller arrow here. You're going to have something like 3H plus, then plus PO4 3 minus. Okay, the dissociation is partial, is weak. It does not. Another way you can define this is that it ionizes completely in water. Okay, or ionizes partially in water for weak acid, and ionizes completely in water for strong acid. So for the purpose of for exam purposes, these are the strong acids, these are weak acids. Then we also have strong bases. An example of strong bases, actually these strong bases, we call them alkalis. Well, not all of them are strong, or you can call them strong alkali, and they are sodium hydroxide and potassium hydroxide. These ones are very, very strong. Okay, and it's easy to remember, just potassium hydroxide, sodium hydroxide for exam purposes. Then for weak acids here, we talk about ammonium hydroxide, or what you call aqueous ammonia. In the other video I told you you can write aqueous ammonia this way as ammonium hydroxide, or you can simply just say NH3AQ. This is also aqueous ammonia. Then any other metallic oxide and metallic hydroxide are this should be weak bases. So you have magnesium hydroxides, you have calcium hydroxide, you have calcium oxide, and so on and so forth. Okay, so these are weak. Now just know that potassium and sodium are strong. Any other metallic oxide or metallic hydroxide are weak. And remember that ammonia is the only base that is not an hydroxide. Is the only base that is not a metallic oxide or metallic hydroxide, but it is a base. because it has features of a base. Now coming back to this, how do I now, okay, I think I should rub this up. I want to quickly show us how acids and bases can come together to give us a salt that is either neutral or acidic or basic. Now, I want to say this. If you want to get a neutral salt, that means where the pH is equal to 7, then it means that you must combine a strong acid and a strong base. You are going to get a very neutral salt, strong acid and strong base. So example of salts that behave like this, that are from strong acid and strong base, you see something like sodium chloride. Sodium is from sodium hydroxide, chloride is from hydrogen chloride, strong base, strong acid. You see that? We have something like potassium nitrate, KNO3. Potassium is from potassium hydroxide, which is a strong base. Nitrate is from HNO3, which is a strong acid. So all of them like this. You can even have Na2SO4, the same thing. Sodium is from sodium hydroxide, which is a strong base. SO4 is from H2SO4, which is a strong acid. Now each of these salts, NaCl, KNO3, Na2SO4, all of them are they have pH that is equal to 7. They are neutral salts. They are completely neutral. Okay? Then if we continue, for acidic salt, if you want to see salt that have acidic property, then it means that that salt is formed from a strong acid and a weak base. In this case, that salt is going to have a pH that is less than 7. A strong acid and a weak base. A good example is, let's say, MgCl2. Okay, magnesium is coming from a weak base, magnesium hydroxide, but chlorine is coming from hydrogen chloride, which is a strong acid. You see that? Another example can be zinc sulfate. This is it. Zinc is coming from a weak. Remember, only sodium and potassium is seen to be strong. Don't forget, any other metallic oxide, metal, is weak, form weak base. Now SO4 is from H2SO4, which is strong acid. So all of these, we can see more. Let's say calcium nitrate. Calcium nitrate is the same thing. This is from a weak base, and while nitrate is from a strong acid. All of them has a pH that is less than 7. Then finally, for pH greater than 7, which is that has basic property, that one comes from a weak acid and a combination of a weak acid and a strong base. That means the acid is very weak. In this case, the pH of that salt will be greater than 7, meaning that that salt will have basic property. It will resemble a base. A very good example is like the one we know, Na2CO3, very common. And as a matter of fact, if you're a student that does titration, you should know that this is one of the reagents, is a primary standard that is used as a primary standard, is always used in titration because it's a base, it has basic property. So it can even react with acid to form salt and water. Now sodium hydroxide, sodium is from sodium hydroxide, which is a strong alkali or base. Then carbonate is from H2CO3, which is a weak acid. You see, so something like this. Another example can be let me say K2S, that's potassium sulfide. Potassium is from a strong base, potassium hydroxide. Sulfide is from a weak acid. So that is another example. You can have sodium phosphate, Na3PO4. This one also, sodium is from sodium hydroxide, a strong base. This PO4 is from H3PO4, which is a weak acid. Okay, so strong base, weak acid, and all of these, their pH is greater than 7 because the base is, they are coming from strong base, but weak acid. So they have basic property. I hope that makes a lot of sense. Okay, so that will be it for this class. Thank you very much.